Hello everyone. In this video, I'll explain about the definition of sets, different types of sets, and two ways of representing a given set. So let us begin with the definition of a set. A set is a well defined collection well-defined collection of objects. So we define set as a well-defined collection of objects. So a set is a well-defined collection of objects. So here the key word is well-defined collection. So these objects can be anything, living thing, non-living things, whatever it is. So it can be anything, but the collection of such objects, it should be a well-defined collection. So the collection has to be a well-defined collection. So what is meant by a well-defined collection? A well-defined collection means well-defined collection. So that means if an object is given, an object is given, then we should be able to tell whether it is given, it is in that collection or not in that collection. An object is given, then clearly we should be able to tell whether it belongs to the collection or not. Such collections are well defined, belongs to it or not. Such collections are known as well defined collection. So let us see examples of well defined collection. So first one, collection of prime numbers less than 20. Collection of prime numbers less than 20. So this is a well defined collection. The definition of prime number is also it is defined properly. So if given a number and less than 20 also is there. So suppose I say 3, so you can easily say that it is an element of, this is a member of this collection. So like that. And if it is given as 6, then it is not a member of this collection because it is not a prime number. So this is a well defined collection, so it is a set. Now second example is collection of vowels, collection of vowels in English alphabet. So here also if I say A, that belongs to this collection. If I say B, it is not a vowel, so it does not. So clearly we can identify, or given any element, we can say that it belongs to, it is a member of this collection or not. So generally the objects which are members of set, which are members of a set, or which are called elements of a set, elements of a set. Elements of a set. So we will be using this word, that is elements of a set. So if a particular object is a member of the collection, we say that it is a member of this or it is an element of this set. So generally we denote this collection or a set with capital letters A, B, C, etc. Suppose the collection of vowels is denoted as A. This collection is denoted as A, and here since A, that is small letter A, is a vowel, it is an element of this set. We can say that it is an element of this set A, and that is denoted as A element of A. A is an element of A. Here this capital A is the collection of vowels, so that is a set. So that is set of vowels in English alphabet. So A belongs to A. This we can read it as A is an element of A, or A belongs to A. So whenever an object is a member of a set, we can use this notation. This is Greek letter epsilon. So A is an element of A, or A belongs to A. So if it does not belongs to that particular, again if a set of vowels, B so B does not belongs to A, so that we can write like this. So B does not belongs to A. Now collections which are not well defined, so that is collection of, these are examples of collection. The first one, collection of most talented cricketers. So this collection is not well defined, so it is not a set. The collection of most talented cricketers in India. If that is collection of most talented cricketers in India, if we give a certain name, suppose Sachin Tendulkar. So we cannot clearly say that it is based on, it varies from person to person. For one person he may be the most talented cricketers, but not for the other person. So that means it is, the collection is not clearly defined. So it varies from person to person. So that's why this collection of most talented cricketers in India is not a set. Then collection of dangerous animals. Collection of dangerous animals in the world. Again, this is also not a set, because depending on person to person, dangerous animals varies. So we cannot clearly define what is danger. And then and it varies from dangerous animal, and we cannot, that is, it varies from person to person. So next, collection of beautiful girls in India. So this is also not a set, because it varies from person to person. So it is not a set because it varies from person to person. So these are examples of collection which are not well defined. So these collections are not well defined. These collections are not well defined, so these are examples of collection which is not a set. Now to represent a set, that is representation of sets. So there are two ways to represent a set. One is roster form. Roster form or tabular form. So in roster form or tabular form, we have to list all the elements separated by commas, then put it in a bracket, this curled bracket. So this bracket will be using to write a set in roster form or tabular form, and we will be listing all the elements then separated by comma. Between two elements we have to write a comma. So for example, set of vowels we can write it as a comma e I o u. So this is the set of vowels written in roster form or tabular form. So we have listed all the elements here, a e I o u. So this is the tabular form for set of vowels in English alphabet, tabular form or roster. So another example for roster form, set of even numbers. If this is the set less than 10, so if you list all the elements here, set of even numbers less 2, 4, 6, 8. So these are the even numbers less than 10. So that means set of even numbers less than 10. So the roster form is 2, 4, 6, 8. Generally, when writing in roster form, we don't repeat elements. An element is written only once. For example, set of letters of the word follow. So when we are listing the set of, this is a letter of the set of letters of the word follow. So when we are listing these elements, F O L W. So there is no need for repeating the elements. When we are writing roster form, the elements need not be repeated. It is to be written only once. Now second way of representing a set is set builder form. Set builder form. So here we will not list all the elements like a, I, o, u. We will write a element, that is this element, it can be x, y, whatever, then we will follow with a colon x, and it is read as x such that, so x is a vowel, x is a vowel in English alphabet. So we will be getting the same elements. If we list the elements, we'll be getting the same as this particular set. Suppose I take this as v, so this is also equal to v. So x such that, x is a vowel in English alphabet, so this is equal to v. So this is the set here. Here we are not listing the elements, we will be writing x then followed by colon. Instead of colon we can use a line like this. This is also denotes such that. So x such that, x is a even number less than 10. So this is for the second one. So that is, we will be getting 2, 4, 6, 8. So instead of listing all the elements, here what we will do is we will be writing x or y, it can be y also, such colon, and followed by what is the property of the property that the elements of the set possess. That property will not be possessed by any other element. So we can easily write the property, then using that we can list the elements of the set also. Now these are the notations used for sets in a number system. So capital N is the set of all natural numbers, that is 1, 2, 3, etc. So this will be 1, 2, 3, etc. Then Z is for set of integers. Set of integers, it will involve negative numbers also. So -1, 0, 1, 2, etc. Then set of all rational numbers. So that is numbers of the form P by Q. So where Q not equals to 0, and P and Q are integers. P and Q belongs to Z. So this is the Q is the notation for set of rational numbers, and this is set of real numbers, that is rational number as well as irrational number. It can be either rational or irrational, so that is set of real numbers. Then set of positive integers, the Z plus, that is for set of positive integers, Q plus set of positive rational number, and R plus the set of positive real numbers. So these are the notations which we'll be using throughout for representing the set in numbers, that is the different sets in number system. Now we move to different types of sets. So the first set is empty set, null set, or void set. A set which does not contain any element is called the empty set, or the null set, or the void set. A set which does not have any element. So for example, x such that x is a natural number lying between 1 and 2. So you know that there is no natural number between 1 and 2. So this is a null set or a empty set. Now y is a point common to any two parallel lines. So two parallel lines does not have any point in common, so it is also a null set. Now when you are denoting a null set, it can be used phi. This is the Greek letter phi. Phi is the notation for a null set. Phi, that is just writing phi, that indicates a null set. And empty bracket, that is also notation. So these two are the notations for a null set or an empty set, but this notation is wrong. So you cannot write like this. This is wrong. So you have to either use writing phi without bracket or use empty bracket. Okay, so this notation is wrong. This means that this is a set containing the element phi, where phi is a Greek alphabet. So this is a set, this is not a null set. This set has an element phi. So whenever you are writing null set, you have to use either phi or an empty bracket. Next is a singleton set, a set containing exactly one element. A set containing exactly one element, that is known as a singleton set. A set containing exactly one element is called a singleton set. So it will have only one element, so that is known as a singleton set. For example, x is an even prime number, so only an element of this is 2. Then x square minus 16 equals to 0, the natural number which satisfies this equation. So it is 4 is the set, 4 is the answer to this one. So it is a singleton set. So a set containing exactly one element is known as a singleton. Now the third type of set is finite and infinite set. A set which consists of a finite number of elements. The number of elements has to be finite, then it is called as a finite set. Otherwise the set is called an infinite set. So if the set consisting of a finite number of elements is called a finite set. If it has no elements are not finite, then it is an infinite set. The set of all letters in English alphabet is a finite set. So it contains finite number of elements, that is A, E, I, O, U. So this set has 5 elements, which is a finite number. So the set of all letters in is a finite set since it contains a finite number of elements. And set of natural numbers, that is 1, 2, 3, etc. is an infinite set because it does not contain a finite number of elements. Similarly, the set of all points on a line segment, this is also an infinite set. Set of all points on a line segment is an infinite set. Now when we are considering infinite set, so here it is not necessary that we can write all infinite sets in roster form. So for example, the set of real numbers, we cannot be described in the roster form. We cannot list the elements of set of real numbers. So that is, it is not possible to write real numbers in roster form because elements of the set do not follow any particular pattern. So similarly here also the set of all points on a line segment, this also we cannot write in roster form. So infinite set, there are all infinite set we cannot describe in roster form. The natural numbers we can write, integers also we can write, set of real numbers we cannot write. Similarly, set of all points on a line segment also we cannot write in roster form. So all infinite sets cannot be described in roster form. Now if a finite set has a particular number of elements, that is finite number of elements, so that number is known as cardinality of a set. Cardinality of a set. For example, here A equals to AEIOU, so that is a set of vowels, so it is denoted by n of A. So n of A equals to 5. So if we take a finite set, we can define the cardinality of that particular set. So it is denoted by n of A. So for example, if A equals to AEIOU, then n of A equals to 5. So that is the number of elements in that particular set. Okay, now next is equal sets. Two sets A and B are said to be equal if they have exactly the same elements. And we write it as A equal to B. Otherwise the sets are said to be unequal and we write it as A not equals to B. So here two sets should have the same elements, same set of elements, then only we say that they are equal sets. Otherwise we say that they are not. Okay, so that means suppose A is equals to set 1, 2, 3 and B is equals to 3, 1, 2, then A equal to B. So here again when we are listing the elements, order has no importance. You can list the elements of a set in any order. So 1, 2, 3 and 3, 1, 2, then both the sets are same. Both the set contains same elements. So it is equal sets, A equals to B. Similarly, A equal to set of letters of the word follow, then set of letters of the word wolf. So both these sets are same. Again we will not repeat the elements as I told previously. So a set does not change if one or more elements of the set are repeated. So there is no point in repeating the elements. So even if it is repeated, it will be the same set. So for example, A equals to set 1, 2, 3 and B equals to 2, 2, 1, 3, 3 are equal. So the elements are repeated, so that means it is the same set as A. So since each element of A is in B and vice versa, so generally we don't repeat the elements when we are writing a set. 2 points to be noted here. Order has no importance when we are writing an elements of a set. Order has no importance. Then second point, repetition of elements. So these two have, we will not repeat the elements, and order has also no importance. Now last type of set is equivalent sets. So two finite sets A and B are said to be equivalent. Equivalent if number of elements are same. Number of elements in equals to number of elements in B. So here elements can be different but number has to be same. So A is equals to 135, B is equals to 246, then n of A equals to 3, n of B is also 3. That is number of elements. So A and B are equivalent. So here whenever we take an equal sets are always equivalent, but equivalent set need not be equal. So these two are equivalent but not equal. So if you take any two equal sets, for example, it is always equivalent. So that is 1, 2, 3. So this is an equal set. So equal sets are always equivalent. So this is equal means it is equivalent also. So but equivalent set need not be equal. So here if you see this example, it is an equivalent set but it is not equal. So when we are saying about equivalent set, it depends on the number of elements. The number of elements has to be same irrespective of the elements. Elements can be different. That's all in this video. Thank you all for listening.